Today we're going to go over the introduction to formal charges. And so the formal charge equation, formal charge equals number of valence electrons of that atom minus the lines plus the dots. And so the lines represent the number of bonds, and the dots represent the number of unshared electrons. And so we're going to grab this information all from the proposed Lewis dot structure. And I say proposed because we're trying to figure out if it is the correct Lewis structure, and we'll need the formal charge to help us get there. So this comes from the Lewis dot structure. And then this will come from the periodic table. Let's go ahead and start with example. So example 1 will be water. So here is the proposed Lewis structure for water. And let's see what the formal charge is for oxygen. Remember, when you're calculating formal charge, you're looking at a specific atom. So you would be able to calculate the formal charge for hydrogen, oxygen, or the other hydrogen. But right now, we're looking at the formal charge for oxygen. So we're going to look at the valence electrons for oxygen. It's in row 6, so that gives it 6 valence electrons. And then we're going to subtract the number of lines or bonds that it has. So if we look, oxygen here in water has 2 bonds. And so 2 bonds plus the number of unshared electrons. It's not asking the number of lone pairs, it's asking the number of unshared electrons. So I have 1, 2, 3, 4. So 2 plus 4 is 6, so 6 minus 6 is going to be 0. So this water is neutral. So the oxygen has no charge on it, and the overall charge of the molecule is neutral. Let's take a look at another example. So example number 2, we'll do NH4. This is the proposed Lewis structure, and let's see what the formal charge of the nitrogen will be. So we'll take a look. Formal charge, nitrogen has 5 valence electrons, and we're going to subtract how many bonds? 1, 2, 3, 4. So remember, the formula was lines plus dots. So lines, there are 4 lines around the nitrogen. So 4 bonds, and then we add it to the number of dots. There are 0 dots around that nitrogen. They're all just bonds. And so 5 minus 4 is plus 1, or just 1. And so this Lewis structure will have a positive charge on the nitrogen. Now, we'll talk later about common bonding patterns, but whenever you see a nitrogen with 4 bonds, it's going to have a positive charge on it. And now we're calculating the formal charges, but later on, as we evolve in the course, evolve in our knowledge, what's going to happen is we're going to be able to recognize that very quickly. Okay, let's do another example. Example number 3 is going to be do CH3. So that's the proposed Lewis structure. Now, if we do the formal charge for it, we'll get number of valence electrons around carbon is 4, because it's in row 4 of the periodic table. We're going to subtract it. Subtract from it has 3 bonds, so 3 lines, plus 0 dots. So it's going to be a positive 1. So we're going to stick a positive charge right on that carbon. And so that will be the correct Lewis structure for that. And we'll do a very similar example. Now when we calculate it, 4 valence electrons minus the number of bonds, so there's 3 bonds still, plus the number of dots, so there are 2 dots or 2 unshared electrons. And so now you're going to have -1, and so we're going to put a negative charge around that carbon. A couple things to note here, going back to this problem example 2, an octet doesn't necessarily mean that you have a neutral atom. So let me note this. Having an octet doesn't automatically mean it's neutral. Right, so that's something to know. So here, the nitrogen has an octet, but it's positively charged. And so when assessing, whenever we assess the Lewis structures to see if they're correct or not, we have to take 2 factors into consideration. The first factor is whether or not the molecule has an octet, or all the atoms have an octet. So do the atoms have octets? So in the NH4 example, the nitrogen did have an octet. The second thing is the compound neutral or is it charged? And so neutral will be more favored than charged. So if you can create a Lewis structure that meets all of the octets criteria for all the atoms, but it's neutral, it's going to be favored than a Lewis structure that has all the octets met but is charged.